Hello and welcome to another video on DesignScript. In this video, I'm going to be discussing translations, rotations, and transformations. So if we look at the reference for DesignScript, available from Help and References, Geometry Library, we can notice that looking at the geometry type, which is what every single object that appears in 3D model space derives from, we notice that there's a base type of translate and a base method of translate and a base method of transform, but there isn't a base method of scale or rotate or any of these other things. That was done intentionally because the primary way you are supposed to be modifying objects of any given type is by transforming it from one coordinate system to another coordinate system. So I'm going to show you how to do that in this video. So we'll import the standard geometry library. So if we have a standard point, we can easily translate it with p is equal to p dot translate, say 10 in the x direction, 10 in the y direction, 0 in the z direction. There we are, we can see it translated. Now, alternatively, we can transform objects, but we can look at transform. Transform takes an existing coordinate system, which is the base coordinate system, and a new coordinate system. So we can have perhaps a more complex model, say a cuboid. And we can create a new coordinate system, the one we want to transform it into. And note that the methods available on coordinate system include things like rotate, as well as scale, and of course translate. So all the things that you're used to sort of doing to geometry are completely available to the actual transform geometry. So let's see. We're going to rotate this now. And we're going to rotate, so rotate takes both the angle rotation in degrees and then the rotation in axis. So we can maybe rotate around 1, 1, 1. All right, so now we can finally transform this cube. Well, why don't we first take a look at what it looks like initially. So that's our cube. We can say cube is equal to cube.transform. And we want to go from the coordinate system to the new coordinate system. And you can see it's been rotated. Similarly, we can actually perhaps scale this. So maybe we might want to scale it by 10. So it's going to be huge. It's a very, very large cube with a very large coordinate system. Alternatively, we can actually set up coordinate systems with, how would I say, shared coordinate system, essentially with a shared coordinate system vectors. And what this means is that normally if we look at this x, y, z coordinate system in the main viewer here, x, y, and z are all orthogonal to each other. That's not a requirement. In fact, actually, any of the x, y, and z can be sort of oriented arbitrarily to each other. So I'm going to create a coordinate system that has this phenomenon of, okay, by origin vectors. I'll have an origin point. Oop. So let's take a look at this now. So if we look at this now, this cuboid, it looks as though it's been kind of like pushed over, turned into a diagonal. But this cuboid, in fact, it, ostensibly, it has orthogonal, say, faces. Every face is supposed to be a rectangular with right angles. But because the underlying coordinate system, the actual underlying kind of mathematical space that we create this cuboid in, has been sheared, has been sort of set non-orthogonally, all the underlying geometry, such as this cuboid, is generated non-orthogonally. And the reason we know this is true is because coordinate system by origin vectors takes what is supposed to be the sort of x coordinate, the x axis, and here I have it in this kind of skewed vector going in 1, 1, 1, and the other vector is kind of similarly skewed. It's this negative 0.4. So using this, you can essentially create kind of scaled or sheared or otherwise distorted geometry without having to sort of recompute, come up with a sort of like new geometry primitive, like the diagonal cuboid. You can simply sort of take existing types but share the underlying or shear the underlying mathematical space to create these kind of distorted forms. All right, well that's the transform operation as well as translate. Thank you for watching.